Let's do all of D here. So state the name of the force that prevents them from colliding. These guys are heading toward each other, right? Well, I'll tell you what, this is positively charged and that's positively charged. So what's the name of that force? What's the name of that force? If you don't know the name of it, use your Google machine, okay? And figure out what's the name of that force that is the repulsion between two positive charges. IB calls it two things, and you'll see it on the mark scheme soon enough. And we've called it something, so there it is, right? At the distance of closest approach, the kinetic energy of both nuclei is negligible. Show the distance is given by this, right? So each one of these has a kinetic energy of EK, we call it that, right? Okay, so the total energy available is twice that, right? Equals the total kinetic energy, right? And then what else do we have? We have three things we have to say. I think we have to say that energy is conserved, right? And that when the particles are a certain distance apart, their energy, their potential energy is what? K Q1 Q2 over R, right? And that formula is in your data packet, right? And so if the objects, when they get close to each other, right, you're going to say, well, they stop. So the kinetic energy is gone. Therefore, since energy is conserved, it equals this, right? The kinetic energy goes to potential energy, right? So then you get this equals this, and then just cross multiply and divide, and you get the R over here, the D in that case, right? Like they want the D. They want you to use D instead of R. The D goes up there, the 2EK goes down there. Should be simple. And then finally, the last one says nuclear fusion of deuterium and tritium takes place when the nuclei are separated by a distance of 1.2 times 10 to the minus 14th meters or less. Deduce that the kinetic energy EK corresponding to a distance D is 9.6 times 10 to the minus 15th joules. You suppose they're just asking you to plug numbers into that? Do you think that's all it is? Okay, so let's see. So 1.2 times 10 to the minus 14th. Plug that in there, right? Plug in, let's see, K is, well, look it up. It's the Coulomb constant in the data packet, right? Okay. Q1 is, well, one of these deuterium has a charge of 1.602 times 10 to the minus 19th coulombs. And the tritium has the same charge, right, because it's just one proton. Right, so plug these guys in for the charges, right? And then solve for that kinetic energy, and sure enough, you'll get that for an answer. I kind of like those where they say, show this answer, right? And you're like, oh, unless of course you can't get that answer, and then it's probably frustrating as heck.